Hello, welcome to Decentralounge, brought to you by Global Stake, your institutional SOC 2 Type 2 certified, truly decentralized bare metal staking service provider. In today's episode, we're joined by Ian Smith, CEO and CTO of Quantum EVM, a pioneering blockchain platform designed to withstand the emerging threats posed by quantum computing. With over 2 decades of experience in cybersecurity, cryptography, and blockchain architecture, Ian is at the forefront of developing quantum-resistant solutions for the decentralized world. Quantum EVM is a sharded post-quantum layer 1 blockchain that integrates quantum-safe cryptographic algorithms, ensuring compatibility with existing Ethereum applications while safeguarding against future quantum attacks. Built on Cellframe's powerful quantum-resistant foundation, it offers a scalable and secure environment for decentralized applications with low transaction fees and high-speed performance. In our conversation, we'll delve into the looming challenges quantum computing poses to current blockchain systems, the concept of Q-Day, and how Quantum EVM is proactively building infrastructure to secure the future of Web3. Ian, thanks so much for being here. Really looking forward to today's conversation. Let's just start with a brief intro about who you are and what brought you into this space and why you think quantum is so important to address as we face these challenges in the future.
Sure. Thanks for having me. I have been in tech since the 90s. I did tech support, Microsoft, and I was in Silicon Valley for the dot-com boom, and I worked on decentralized networks as well as clustered systems with quorum-based architectures for file systems and for load balancing. I worked on firewalls, security. I even worked on Microsoft Exchange when I really had to. My tech experience has gone all the way from AI in 2002, 2005, and 2011 to cryptography in 2002, 2003, and automated trading and all sorts of things that became more common later on. I'm usually too far ahead. As for Q-Day and what is the quantum threat that's coming, well, the quantum computers are able to do physics to calculate questions that we have about math. And physics will turn the public key into the private key. And unfortunately, the next target, like what's the next thing that quantum computers can do? Well, the very next rung is breaking Bitcoin and Ethereum public keys into their private keys. That is the next sort of milestone on the quantum journey. And for Bitcoin, that just means some of the addresses are exposed and some have known public keys, about 6 million Bitcoin worth. For Web3, that's pretty much everything. The proof of stake system, some of the protocols, like the Cosmos protocol, has the public key in the network messages. Sometimes it's the dApps. Some of the bridges have both an admin and they have public keys that are exposed for managing the decentralized version of their bridge. So this is devastating both to users and to infrastructure, and will also break ZK snarks because they use discrete log as their fundamental security assumption. So they're going to be able to break the same, using discrete logs to break Bitcoin and using discrete logs to break ZK snarks. And unfortunately, everybody's using ZK snarks. Even Starknet is using snarks. They labeled them Starks for some reason, but they're actually using ZK snarks.
For the less technical people who may be listening or watching today's episode, let's just like a quick primer about like a little bit, just unpacking what quantum computing is and like what we've achieved so far. I mean, we talked about sort of breaking these private keys or turning them into public keys. So maybe just like a layman's version of what this is going to do, sort of the risk that's being exposed with this.
So there is a lot of things that can be done by quantum computers. The layman's version is that we can do really hard math that we can't do in silicon, which is all addition based and comparison. And we can do about 45 different really, really hard math problems using physics. And this goes in three stages where you have to like load the question in, which is non-trivial. It's not easy. And then the quantum circuits will find the answer, and this is a different method for every single type of question that's asked. And it's also different for the hardware architecture. And then we have to read the answer back out. And there's a lot of things that go involved in that, and there's probably several hours to unpack how that happens. But the main thing that happens is that physics does math we can't do on silicon. And as soon as you can read that answer out, that's someone's private key. They're using Shors, using Grovers. You like are searching a database, or you're looking for a duplicate hash, or you're solving a Sudoku puzzle. There's lots of different ways that you can program Grover's algorithm to find things, but it's a small speed up. The next step is Shors breaking public keys into private keys, and then a few years after that, they're looking at breaking 160-bit hashes, and then maybe in 30 years they'll be able to break 256-bit hashes. We don't know. It might be 2040, it might be 2070, it might be never. There's a lot of questions about what the upper bounds and what the upper capabilities are.
So when we talk about Q day, there's no specific set date for that, or would these first level disruptions start to happen sooner, and then maybe some of these other like breaking of the higher hashes happen, like you said, at a much later date?
We won't know when Q day happens even after it has happened. We will guess, and we will seek confirmation. Was this Q day? Was this Q day? We don't know. For a lot of people, Q day is when Satoshi's coins get moved. But if Satoshi's coins are left intact, has Q day occurred? People would say, well, no, it's free money. That's how we'll know that Q day has occurred. But if the attacker's like, well, we're not going to tell anybody, and we're also not going to touch Satoshi's coins, why would they touch Satoshi's coins if it would tell everybody? So Q day is something that we're going to be guessing at unless there's a press release or Satoshi's coins being moved. There's a lot of reasons why Q day should be kept quiet. One of them is that it will also not only break Bitcoin, but it will break the Fender-Foe missile identification systems for missiles chasing airplanes. So if you do Q day and you don't tell the other side, your airplanes are immune to their missiles. Will Q day be announced? Probably not.
So,
was there a second part to that?
No, no, go ahead, Miles.
No, I was going to maybe lead into Quantum EVM because, hearing the repercussions of Q day, what can happen with quantum computing, from your perspective, would you say that you're building Quantum EVM out of necessity and not just a nice to have, and go a little bit more into the thought process behind, why you're doing what you're doing?
I read some papers on the new Shors algorithm implementations, and the algorithms are basically like in 2023, they shaved about 5 years off of the expected hardware requirement. So basically, as the hardware improves, we're able to solve larger and larger problems. As the algorithms improve, you need less and less hardware to solve those problems. And they got really good. In a network mode, they're talking about breaking Bitcoin in 10 minutes with 6 million qubits. And the estimates from 2022 were saying, oh, well, it's going to take at least 200 million qubits before you're going to be able to break a single key. And that 6 million 10-minute was actually a multiple key solve. So it would solve a batch of private keys in 10 minutes, just running in batch mode. So that's a scary thing. And when I read that paper by Daniel Latinsky, how to solve elliptic curves in 10 minutes with 6 million Toffoli gates, 50 million Toffoli gates, I started the QEVM, and I said we have to do this now. We don't have a good migration path for Web3. Bitcoin has a good migration path with BIP360, but I'm concerned that it won't be approved or approved in time. And so it may just sit there, on the vine, ready to be implemented, and Q-Day may come and go without actually using BIP360. For Web3, there's more use cases enabled, and we don't have the same sort of systems in place for improving Web3 to make it quantum safe. And part of the reason is because not only does the proof of stake system have to change, not only does all of the storage systems that Ethereum just adopted, those have to change, and all of the wallets, but it's also all of the smart contracts that are sitting on the chain. All of those admins and all of those owners, those all have to change also, and everybody has to migrate. So I don't think that you're going to be able to get 100% of Ethereum wallets to migrate, and I don't think you're going to be able to get 100% of those smart contracts updated. So we have a clean ledger, and we only use post-quantum cryptography. No ZK snarks, only safe cryptography. So we're going to be implementing fully homomorphic encryption in order to add a privacy layer, and that privacy layer would be opt-in as opposed to mandatory. We'll have whitelists and blacklists on the chain also, so that we can be compliant and operate in Europe. But it's possible that people could ignore the blacklist if they wanted.
So is that one of the key differentiators? Like, I know you referenced elliptic curves, and then you just talked about FHE. So I guess if ZK snarks can be broken by quantum, but FHE can't, is that part of the base layer for what you're building into Quantum EVM? Like, take us through the design a little bit. Like, is it because you've learned so much about what quantum computing, like how it poses the threat and the risks, and then that went into sort of the design of Quantum EVM as you were building it?
Partly. What I am aiming for with our design for Quantum EVM is to have an easy migration path. We want, and we're doing extra work, and we're delayed by trying to make this happen, a 15-minute migration path. If you can take your dApp and redeploy it by recompiling it and just using a wallet to sign a transaction, and boom, you have a backup copy of your smart contract, change the library name on the website to have a Q instead of web3.js, it'll be qweb3.js. Then that 15-minute migration is done. So that's the overriding goal. We want to be able to make it very easy for people to migrate. And that our business model is mostly based around licensing our EVM as a clustered node for other EVMs. And there's over 300 blockchains that run EVM right now. Some of them layer 2, some of them layer 1. And what we wanted to be able to do is say, hey, look, bring everybody over. We'll give you your own chain. Just pay us a very small licensing fee, and you're quantum safe now. Just sign the transactions and migrate. And we developed with one of our partners a migration tool, so people can actually migrate their token balances and their NFTs from other chains to our chain, and they will own those assets on our chain. So it's not just a smart contract migration; it's actually the account, the user's balances as well. And there's the library that's required for that.
Is Quantum EVM already currently in a testnet phase, or is it live and you're already working with some of the EVM chains that have already made that transition over to be quantum safe? Or is this something that you guys are still trying to, in the early stages of having talks with current chains to get them to become quantum proof, if you will?
So we are in a developer testnet, and the developer testnet unfortunately has hit a snag. The Ethereum code is really awful. And that includes the compiler. The compiler requires that you have a 20-byte address. I'm like, well, what if we just ignore the compiler and then substitute in 32-byte addresses? And this is the 160-bit going to 256-bit question. This is something that Ethereum says that they have to do. It's just that they've sabotaged that process at every single tool and every single layer. And I really wish that they'd made a single or maybe two variable types, but no, there's 8 different ways of encoding that address. And that was a mistake on their side. Why would you have 8 different variable types for a single piece of information? So we're still in developer testnet, and although we have had smart contracts execute in developer testnet, they are not ready, and this is going to require a little bit more work than I was hoping that we could get away with doing less. But we're going to have to correct and refactor some of the code, and it looks like we're going to have to break compatibility with Ethereum in different ways at the virtual machine side. Smart contracts should still run normally, but in terms of like the code and the tests, we're going to have to cut it. We're going to have to really do some damage inside there. So we're still in developer testnet, and we're having to take a step back because the code is awful. And I'm hoping that we're going to have our main testnet in June, followed by a rapid mainnet also in June. I want basically a 2 or 3 week, let's beat it up hard and fast with tons of smart contracts, tons of activity. If we're not pushing those machines and we're not pushing that blockchain with a lot of transactions, then we're not testing very well. So after we fix the bugs that we uncover, we should have our mainnet. I don't want to have this idea of like a 6-month test net that's just, incentivized and preaching. No, we're aiming for a technology solution, not a marketing gimmick. And we're aiming to make this available as soon as we possibly can. And we're working hard. Lots of overtime.
Sounds like it. I mean, it sounds like quite a challenge too. I mean, you clearly already very future facing and forward thinking in terms of just being ahead of the curve with all the quantum stuff and trying to, make sure that threat never becomes a reality. What about the changing architecture of ETH and the EVM? Whether it's the Pectra upgrade that's coming, that maybe it doesn't have any kind of impact on what Quantum's building, but recently Vitalik put out a blog talking about eventually one day getting away from the EVM in a virtual machine and going to sort of like a RISC-V architecture. What kind of impact might that have on not only Quantum EVM, but just the quantum problem in and of itself?
Unfortunately, Ethereum has decided to adopt SVM, which I have read but not confirmed is not quantum safe. So their data storage is also going not quantum safe. That's a problem. Initially, the SVM storage was rejected as a result of it not being quantum safe, and just it got quietly added to the changelog for future patch. In terms of the RISC-V architecture, Gav Wood created Ethereum, and then he left Ethereum and started Polkadot, and then they went RISC-V architecture, and Vitalik's like, wow, that works really well. Maybe we should do that too. He didn't give credit to Gav Wood, but I mean, they're running like real-time shooters on chain as their performance test, and Polkadot has a good architecture. It's just that I don't want to make breaking changes with this adoption. And what they're talking about doing is keeping everything the same. They're going risk V and they're going back and forth. And the Wizards thread on this, that's their discussion forum, goes back and forth and talks about, well, this is really a ZK optimization and things like that. And we're not optimizing for ZK. So the advantages that risk V would pose to the immediate future would mostly be for ZK. And that was basically admitted in the thread. And we're blocking ZK. Like, don't touch us with that stuff. Keep it away. So I don't really feel like we should optimize for ZK at the hardware level. Now, in terms of virtual machines, getting closer to the hardware is definitely better. It's just that most of the significant impact of that risk V proposal was ZK related. What I would love to see instead of doing risk V is doing GPU instructions, partly because they're more common and they're faster, and there's a bit of a balance that you need to do on that GPU programming because you have very limited memory. So instead of doing the risk V, we might just jump straight to video card and just straight to GPU instructions. But there would have to be a series of breaking changes. Another thing that I think is really important is going to parallel execution. And EVM is inherently single thread. So you might have 16 cores in your machine, but only one of them will do EVM instructions. And it would be much better to be multi-core and to do all of this work in parallel. And we're looking at like how can we make the RPC architecture more multi-threaded, and how can we make all the SVM more multi-threaded. And we have to do a whole bunch of safety upgrades to make a lot of that stuff happen. And we're changing our execution. We're not doing an auction in the mempool. We're doing a line. You get in line first, you execute first. And this solves MEV. Just get in line. You'll have your transaction at the same cost as everybody else and at the same point in line. So that solves a lot of the architecture problems, I think, with the economics of exploiting users for validator profit. But there is a lot more things that need to change than just the instruction set. And I think multi-threading is a bigger deal than risk V.
Thank you for that. I mean, we're obviously dealing with an extremely technical problem, and for a large portion of the industry, this threat isn't really widely recognized or fully understood yet. And so my question to you is, how do you balance being early on quantum security with the risk of being too early, like you alluded to for some of your previous experience in your career? How are you educating people that now is the right time to adopt this mindset and be prepared for Q-Day, essentially?
So I maintain a spreadsheet of everybody who claims quantum safety, and there's about 45 entries on the list. And 3 of them are legitimate. So there's a lot of scams in this space. And I think that the biggest 3 quantum safe chains, XX Network, Hedera, and Algorand, none of them protect a single user. And the biggest threat is that it's not just the user wallets, but the quantum compute attacker can become anyone inside the blockchain ecosystem. They can't become maybe the website, but they can become any wallet, right? They can replace contracts. They can go anywhere in the ecosystem. And the way that I balance this for most people is, as soon as the market realizes quantum is a real threat, it might come as, in 2027, paper that came out this week, maybe even 2026, because the hardware requirements went down a lot. So now we're facing basically an imminent threat, and the users will price that in. They're going to expect these chains to die, and they're going to probably sell that in favor of something that may survive. So if you want to, signal to your investors that you're actually looking longer than 1 quarter or 2 quarters, you should do quantum safety now. And especially the layer ones. A lot of these gaps, they're like, well, that's our layer 1 responsibility. That's not our responsibility. Well, maybe you should switch layer 1s. And they listen to that if they intend to stick around for longer than 2 years. It's this great litmus test. Are you guys planning on being quantum safe? If they say no, I'm like, even if it's 2027, I'm like, oh, you're going to rug pull. Anybody who's not planning on quantum safety, if they don't rug pull you, the math will.
No, there's obviously a lot to stay on the ground with and stay updated with. So for our listeners out there, where can we follow you, social handles, just to stay updated for the quantum problem, Quantum EVM, your own personal thoughts, any handles you want to link for the crowd?
So we have Quantum EVM on Twitter. This is all no spaces in any of these. So Quantum EVM on Twitter, Quantum EVM on Telegram, Quantum EVM on Linktree, which links to all of our socials, and also on YouTube. And if you want to see me, calling people out and causing problems and linking to source code that says the opposite of what the marketing says, that would be Ian Smith HSA. And I'll probably show up in the top 5 Ian Smiths now. It's weird. I'm actually an Ian Smith that people could find. It's creepy. But if you go to quantumevm.com, you'll see links to all of our socials and also my LinkedIn.
All right, awesome. Well, thank you so much for taking the time with us today, Ian. Really fascinating stuff. And I'm glad that somebody's out there trying to prevent all this from happening and having Web3 implode. So glad to know that Quantum EVM is out there. For those of you who are watching or listening to today's episode, we'll be sure to link all those socials in our clips and everywhere else that you're watching or listening to the episode. Thanks so much for tuning in to Decentral Lounge, and we'll see you on the next episode next time. Take care, everybody.
Thank you.